Okay, everybody, welcome to Human versus AI, how to ship secure code. My name is Joseph. I'm a security specialist at GitHub, the platform where 100 million plus developers are building, scaling, and delivering secure software. My team is focused on open source security. And I'm asking you, who here is having open source components on your pipelines? Many of you, almost everybody. And if you are driving a car or if you are using a fridge, it's highly likely that you have open source components in other aspects of your life. My team has found and helped fix 500 security vulnerabilities in the open source software in the past 3.5 years, with a fixed percentage of 96%. Which is pretty high, having in mind that this involves a collaboration between two different worlds. The world of software developers and the world of security experts. And this collaboration is hard because, among other things, the numbers don't help towards that direction. We know that there exists one application security specialist for every 100 developers. Who is a security specialist here? Exactly, one. Nobody. You see this straight away. The good news, however, is that with AI, we can use this collective knowledge that is out there, the collective knowledge of the security experts. And AI can bring it to our fingertips, to every next keystroke. Because by definition, AI is here to mimic the problem-solving capability of us, of humans. This means that something that is solved elsewhere, meaning also in a different time, it can be used right now and, of course, in the future. Traditionally, we have used AI to be more productive through delegating. And in the future, what can come in mass consumption is what we use already, and then we can have AI embedded in our daily life. I put these two pictures on purpose because I want to draw an oxymoron. For me, it's a bit contradicting that behind these great applications of AI, there are thousands of software engineers, but behind these software engineers, until very recently, there was no AI. There was no AI to help them with their craftsmanship. And this has changed. It has changed because we introduced GitHub Copilot. Who is familiar with Copilot here? Perfect. For those that are not, I want to show you an example that resonates with me a lot. Line 3 is a pain for me. It's a regex. I don't discuss the security of it. I just discuss how much time it will have taken me to find out the syntax, write down what I want to write, which is like a US phone number, test it, and so on. I don't expect a lot of you here to need less than 2-3 seconds like Copilot to come up with this pattern. And no wonder why 46% of the code being written nowadays is AI generated. Our client, Mercado Libre, think about it as the Amazon of Latin America. Until very recently, they had the largest market cap in the area. They are seeing a lot of progress with Copilot. And we are talking about a company that is merging 100,000 pull requests every single day, a company of 13,000 developers, 9 of which are using Copilot, seeing 50% reduction in their time of writing code. They can, of course, use the other 50% for those things that they never had enough time to do, which is something else that resonates with, I guess, a lot of us. Our vision with GitHub Copilot is this X here that marks the spot for the unknown and for everything. We want to bring AI to the end-to-end software development lifecycle. We are going to announce these innovations in 2 weeks in our flagship conference live in San Francisco. You can join virtually for free in November 8 and 9. And we are here today to see 4 ways that developers can use AI to leverage the world's security knowledge, starting from the very demanded writing safer code. This way, we can start from left. We are not shifting. Let's see this snippet. If someone can help me by spotting what is wrong here, you can feel free to shout. Perfect. Which line? Perfect. So someone has spotted it. I'm going to use this SQL injection example because I expect a lot of you being familiar with it. Of course, what we show in this talk is also valid for any other security bug. Someone can exploit by passing user input to drop the users table or create an admin users for themselves with elevated privileges. This is because there's no control of the input that gets into the code base. Let's see how we could fight against that with AI. Of course, someone can delete this vulnerable code, and the code in gray is the code that has been suggested by an AI coding assistant. Does someone here have further security concerns? Perfect. I don't expect people to come up with this. It's more advanced, and that's exactly why I'm going to use my Copilot, because I want to bridge the gap between the 1 and the 100 that we've seen before. And I'm asking, I have this concern, in line 22, maybe I'm thinking there's a missing control because an attacker can still achieve the same problem we've seen, the injection, by passing an object in JavaScript that is casted into a string. You shouldn't worry about the technical details. They are not important here. What I'm trying to show you is that right in my editor, I can have help, I can have direction, and I can have code with a control that is helping to go over this bug. This is right here, minimizing the gap we just saw. The common mistake here, it was human-generated, and it's happening because first, we didn't give the right context. We didn't provide the requirements in a form of a comment. And of course, we also didn't give the right space. So you can't expect an AI coding assistant to come in on your infrastructure because it's out of bounds, or your security culture, for instance, or for example. Here's how someone could prevent this from happening by giving the context and then coming to the line, what is now 23, giving the right space, adding the control. Of course, I've done this in 2 steps. If you want to do it in 1 step, you can start from the context, and then you can go down, delete the whole snippet, and you can come up with code that is bulletproof. It's avoiding injection in any of its variants in this case. Another step we took towards a more secure future for developers is the security filter. GitHub Copilot has been trained in all public code. That, of course, includes code that can be vulnerable or lower quality. With the security filter, we are preventing these vulnerable suggestions from being presented in front of you. However, I'm not here to say that we reach the maximum capabilities and that it's bulletproof. I'm here to give you a disclaimer that Copilot is your co-pilot. You are the pilot, and you should follow best security practices, which include testing all your code, including the code that has been suggested to you. Let's understand this with a demo. In this case, I can ask, list the security issues you see in this snippet and propose fixes about them. Of course, here we have a SQL injection that is in a very basic variation. Copilot have seen this a lot of times. It's pretty able to pick it up. But when it comes to more advanced problems, we are gonna need security tooling. However, this is still progress because you have your AI assistant next to you during development. You can pick up the low-hanging fruit. And anyway, when you push code, you should have, it's the best practice to have, a security tool that is going to pick up problems upon pushing. So before going into that, I am iterating again that the best practice is to use Copilot for what it has been created for, to be your AI coding assistant, your pair programmer, and use security tooling for what it has been created for. The AI model is designed to predict the next words, in this case, the next code lines. An advanced security tool is built with advanced capabilities to pick up problems everywhere. This brings us to the second case that you can use AI, which is to find a security issue. For this, I'm going to use static application security testing through CodeQL. CodeQL stands for Code Query Language and is the machine behind GitHub Advanced Security. You can be a consumer of it. It takes 2-3 clicks. It can be in your CI/CD pipeline. Every time you push, you get alerts with a lot of explanations, references to official documentation of why we think it's a problem. And everything happens in a PR, in a pull request, so you can have a conversation with your team. Of course, you can be a query writer like my team is. Again, referring to Mercado Libre, the e-commerce website of Latin America, they were able, using our GitHub Advanced Security, to give feedback to their developers early and avoid problems in production. Why they want to do so? It costs millions to fix something in production, and it costs 4 digits maximum to fix something in development. I want to show you quickly how it works. Here we have a super simple Android application. Imagine like an app that is using your username and your password to authenticate you. Of course, this opens the door for someone to enter without any real username or password. In this file, security test, I wrote 6 lines where with CodeQL I described what I want to find. I didn't say how to find it. And then I can follow these high-risk areas around my code base to come up with potential problems. The real power is our community. Mercado Libre is part of our community, and the same for other enterprises. My team is part of the community, and of course, other independent bug hunters around the world. Why is community important? It's important because a client can inherit the security skills and the talent and the maturity of other community members. For instance, someone, again, in Mercado Libre, Buenos Aires, super advanced security team, they can commit a query to us, and then someone can wake up in the other side of the world, let's say in Australia, the other morning, they can run their code, and then they inherit the same problems that the other team in Buenos Aires has tried to fix. Same happened with Log4j. Now, let's introduce AI to the equation. Instead of me going manually over these queries that has been contributed by the community, I can ask AI to give me queries of the past that have been committed to us, and I can use them as the basis of another query by asking, of course, for a customization. Why do I do this? My code is vulnerable in this case to SQL injection, but this is very generic. There are dozens of variants or variants of SQL injection. It can occur in so many ways. If instead of me going manually over those queries and reading code, I can ask, okay, suggest to me something. Here I have a short list, and I can start by being productive and from another initial point. The usual way is to give the context or the requirement in the form of a comment, and here you expect to have code about it. In this case, I'm looking for DOM-based cross-site scripting. Here is the code. I'm going to run it, and I can find those instances that my code can be vulnerable for that. Finally, I can use AI to explain code to me step by step. Again, this bridges the gap of a beginner trying to understand what is going on, asking senior people or online documentation of what's happening instead of having a step-by-step solution of what is happening. Finally, and I find this very exciting, it's one of the slides I introduced last night. We have used AI to model the way we are looking for vulnerabilities. Every vulnerability has a special architecture. They occur in a specific way. We need to model it and give you CodeQL functions to be able to find it. With AI, we were able to boost up this process, and we have found real vulnerabilities. I include them in the references. This is a game changer. For those interested, a quick summary is that there are 10 programming languages supported. It's community-powered, and we have AI modeling behind the scenes. The third case that you can use AI to leverage the world's security knowledge is through developer training. Let's put ourselves in the case that someone has seen this alert about SQL injection. They can Google it, and they can arrive in blog posts that can be outdated. But the number one thing is that they are going to lack personalization. So I can ask my AI coding assistant, OK, explain to me this problem that we have found with examples. However, what I have personally found in the past is that I have a problem connecting the theory to the practice. And again, there are variants of SQL injections. By asking that, OK, connect the dots for me. Tell me exactly how my code can be vulnerable and show me how you can exploit it. You can have personalization in the way you get training about the problem in your code. And of course, you can be faster and you can build a background about it. Again, about the specific variant that your code is suffering from and can be different from anybody else. The fourth case is security guidance. I have put an asterisk next to the word guidance because it's the first time we are going to prompt for something about security. It's beyond code, and our assistant was created for code. We are going to use fuzzing, which is a hacking technique. Hacking is not always about penetrating into somewhere and stealing data and so on. Sometimes it's about throwing a lot of things and see if something is going to break or if it's going to have undesirable behavior. For this case, I want to ask my AI coding assistant to fuzz my code. If I ask a human one, maybe the answer is like, oh, I'm here to program, I don't really do security stuff. However, the AI ones can be a tiny bit more helpful by giving you the theory behind fuzzing and some code as an example. Here, I want you to remember that in the same way you are the pilot when it comes to software, when it comes to security, someone else is the pilot. Maybe it's your security specialist. So it's good to ask them to validate what you have on screen. And of course, themselves, the security specialists, can give the requirements, in this case for the fuzzing input, making sure that they want them asking for ones that are unexpected or invalid, so they can come up with code. Here we have a Python script that generates for them these hacking inputs. If we ask any security professional, at least the ones that I know, they will tell you that the process of coming up with that Python script to attack your code is repetitive, it's time-consuming, and it's daunting. They can also use Copilot to come up with a script that can attack the code so that they can be faster, and you can do it as a developer. Just make sure you validate with them. Finally, there's this blue text you see. It's suggestions that are auto-generated, and they are designed to keep the conversation going. This way, you can keep building more background with your AI coding assistant before you proceed into doing something that is security related. And you will always have blue text at the end. In this case, is trying to help you to automate this process of testing. This slide is very important. It starts with privacy. Whenever I gave this talk, someone is asking me, or many are asking me, okay, but is now Copilot or GitHub or Microsoft, the parent company, going to steal my code and give it to other clients? Are you gonna learn from my code? Are you gonna suggest my code to others? Are you gonna learn from my context, learn from my prompts? We have built this website. It's called GitHub Copilot Trust Center, which includes dozens, if not hundreds of those questions. And I want to answer the one I have just mentioned. If you have the business license for GitHub Copilot, nothing is being retained, and you don't even have the option to enable stuff to get saved and used. For instance, the code that is given to you is not, or the code you give to us as context is not retained. We don't learn from it. Your prompts are just used to give you code back as suggestion, and they are not retained. And if you are having the individual license, then you can have the option to opt in or opt out from training the product in the same way you have in other software. But again, for business use, you don't even have this option. There's no like enable on or off. Now, back to this. There's one application security specialist for every 100 software developers, which is a current problem. I want to see where we are with the adoption of AI. We have run a survey where we have asked 500 USA-based developers that belong to companies of 1,000 plus employees. And these developers have experience between 5 and 10 years. Some questions. The first was, what are your teams spend most of their time doing? Surprise, surprise, they are spending most of their time writing code. But very shortly behind, we have finding and fixing security vulnerabilities, followed by getting feedback from end users. What answers follow is around communication and trying to understand what they have to build, communicating with their teams synchronously or asynchronously. What that second field shows us is that there is a lot of importance given from the board of directors and in general from these companies to cyber security. And they are using a lot of their time reactively. Finding and fixing is a reaction. The second question, we inverted it, and it became, where will you spend your time should you have more time because you are using coding tools? Code reviews and security reviews both scored 45%, followed by design reviews and feature planning, which shows us the need for security reviews to happen early and at least happening, okay? Not being an afterthought. And finally, the question was, okay, how many of you, of these 500 people, are using coding tools? And we had everybody but 50 people using AI coding tools, both inside and outside their working environment, okay? And we are talking about 500 US-based developers of big companies. This shows us that AI is already here, is already transforming the industry and how developers work day to day. As the previous speaker mentioned, at some point, someone else is gonna use it and you are gonna be really needing it because you are gonna fall behind. Today, we saw 4 ways developers can use AI to leverage their world security knowledge. Starting from writing safer code, of course, by providing the right context, the right space, and by remembering that you should follow best security practices, like testing all your code, including the code that has been suggested to you. I'm happy to see a lot of phones taking photos of this slide. Finding security issues came second with CodeQL, the machine behind GitHub Advanced Security. It's our leading semantic code analysis. You have the power of community and AI modeling behind the scenes. developer training because it's all about personalization, helping your developers, connecting the dots between theory and practice, helping your developers to understand why their code is flagged as vulnerable, why they have this specific variant in their code. Finally, security guidance, because security experts can also use it to come up with code, and you can also use it as a developer, validating, of course, with someone that is focused in security. I want to show you this. It's a game I have developed recently. It's called Secure Code Game. It's free. It's given to you through GitHub Skills. It takes 45 seconds to set it up by just clicking a button because we are using GitHub Codespaces. For those that are not aware, it's a code editor in your browser. You have 60 hours for free every month. And why I want to show you this? Because as a security specialist, my passion are developers. When we did this 6 months ago, was an experiment. And 2 weeks ago, I was speaking to the Chief Information Security Officer of a Canadian company. It's not a big company, but it's up and coming. They have around 200 employees. And they told me that they have used it for free, of course, as is open source, in a local fixathon, hackathon they did. And this person noticed that right after, in the next week, he noticed 3 things. The developers of his company were able to spot some of the problems they had in their software security education, but more importantly, increased communication among developers and security people in the company, and finally, increased sense of ownership. Security wasn't someone else's problem, it was everybody's problem. How it works is that the first season has 5 levels. Every level has a code file like this one. You have code that is functional but vulnerable. You have a hack file implemented by me and my team. And the moment the hack file, it stops being functional, it stops hacking your file, you can progress to the next level. In around a month time, we expect to release a second season exploiting code in JavaScript, Python, GitHub Actions, and Java. Again, this is given for free in GitHub Skills, and you can open it in Codespaces in a minute. Same like a lot of companies do engineering through Codespaces, so they don't install things locally. Finally, we are here. We have a presentation here. You can find us at our booth. There are people that are way more knowledgeable than me, and in an evolving digital era, one can join us as we build the future together by visiting our booth, as a wise man sometime said. Thanks a lot.